let's go ahead and get started on the next part that we did on Friday, which was finding patterns in these tables, and then we're going to try to connect it to the definition of a polynomial. So if you look here, right, what do you notice is the pattern that's occurring with these numbers two are right over in this section here, right? Just look at it for a minute. Right. Well, if you notice, we're just adding by 5 every time, right? We're adding by 5 every single time. Right, well, 5 plus 5 plus 5 is 10, and 10 plus 5 is 15, and so forth and so forth. Now, one of the ways that we could obtain this, right, is, well, if we look over here, right, what's 10 minus 5? Well, 10 minus 5 is just 5, which is why this is one of the ways that we could get that number, right? Well, what's 15 minus 10? Well, 15 minus 10 is just 5 as well, so that's where we're going to get this number, right? And we could do that anytime we subtract these numbers up, we're always going to get 5 here. All right, now that's one of the patterns that we notice, right? And what does that mean, right? Well, this is actually and I'll write up here D1, okay? And what this basically represents is it's basically saying if it took the very first time I subtract 10 minus 5, I got 5. 15 minus 10, I got 5. 20 minus 15, I got 5, right? 25 minus 20, I got 5. If I subtracted these numbers, and when I subtract them the very first time, and I get the same exact numbers here, right? We get the same constant values here. That tells me it's degree 1, okay? Which means that if we were to try to write an equation for this, it's telling us that the degree has to be 1, right? It's telling us that our highest exponent has to be 1. Remember from the previous video that this just represents the highest exponent. All right, so if we wanted to try to write an equation like this, we're going to get y equals, right? And just like before, if you look back on your notes, hopefully that you took on the definition of a polynomial, right? We're gonna put the letter A. We just start with the first letter of the alphabet, right? It could be any number. We just don't know what that number is, so we're just gonna let it be a letter for now. And we're gonna get AX, right? Well, according to what we just did, right? If it takes the very first time to subtract these numbers to get 1, well, if it takes the first time we subtract 10 minus 5, we get 5. 15 minus 10, we get 5. That tells us that the equation of this table is going to have degree 1. So that means that, like I said, it's the highest exponent, so this has to be a 1 here, right? Well, now we're going to get plus b, and we just go down the alphabet until we get x to the 0, right? So we get b times x to the, well, what's 1 minus 1? Remember, we're just going to keep going down by 1. Well, that's just x to the 0. But do you remember what is x to the 0? Well, x to the 0 is just 1. And what's b times 1? Well, that's just b. All right, so this would be our potential equation for this table right here. All right, well, let's look at another example and see if we can kind of make sense of that. All right, so let's go ahead and hit new. Here we have this second table here, and what we're going to do is we're going to try to find patterns again, right? Now, you can tell that these patterns are not very nice, so we're just going to start off and do 11 minus 7, oops, 11 minus 7, which is 4, okay? Then we're going to do 21 minus 11, which is 10, 37 minus 21, which is 16, 59 minus 37, right? So 59 minus 37, it's got to be 22, right? 87 minus 59 is going to be 28, all right? And as you can see right here, we just stop for a moment. Do you notice, right? Would you agree with me that these numbers are not the same? Right, so before the number last time we got a bunch of 5s. The very first time we subtracted, we saw it was just adding by 5. Well, here we're adding by 4, then by 10, by 16. All right, so here it's not the same, right? And so we're like, well, what can we do now? Well, we just repeat the same process. So we go over here. Well, what's 10 minus 4? Well, that's just 6. What's 16 minus 10? That's 6. What's 22 minus 16? 6 again. And 28 minus 22, there we go, it's 6 one more time. So if you notice, now we figured out the pattern on this table, right? Well, how many times do we have to subtract to get this constant term of 6's here? Well, we had to subtract twice, so we're going to put D2 up here, okay? Now, because we had to subtract twice, that tells us our degree is 2. So this numbers here doesn't mean anything, right? It's just how many times do we have to continue to subtract and how many rows do we need to get in order to get a constant term every time? Well, we get 6, 6, 6, 6, right? So we know now that if it took twice, I put D2, which tells me that our degree is 2. So if I go to write an equation for this, I'm going to get y is equal to, okay, ax, well, what is the height? This, remember, means the highest exponent, and if our exponent has to be 2, what should it be right here? Well, exactly, it has to be 2, right? So we get y equals ax2 plus bx, right? Now we just go down the exponent. Well, what's 2 minus 1? Well, that's just 1, okay? And then we just keep going down until we get x to the 0, so we get c, right? X, well, what's 1 minus 1? Well, that's 0. But what is x to the 0? Anything raised to the 0 power is just 1. So we're just going to get c times 1, which is just, yep, you got it, c. All right. And we have made our general equation for this table, right? If we could find out what the a is, what the b is, and what the c is, well, then we would be able to find what equation matches this table here.